Part B, we calculated for the landing speed for any object that's released from a point at infinity. This landing speed is regardless of the mass of the object. So whatever the mass, if the object is released from a point at infinity, it will arrive on the surface of the mass at 5,000 meters per second. Now I'm going to tell you that this landing speed is also the escape velocity from the surface of the mass. That means whatever the mass of the object, if you are launched from the surface of the mass at 5,000 meters per second, then you can escape. You can arrive at a point at infinity. If you have a speed less than that, you will not be able to reach the point at infinity, and you'll be trapped in the gravitational field of mass. Why is this landing speed also the escape speed? The reason is quite simple. The amount of GP that you lose in going from here to here is also the amount of GPE you must gain to go from here to here. Therefore, the amount of KE you will gain in going from here to here is also the amount of KE you must lose in order to go from here to here. Alright? That's why the landing speed is also the escape velocity. So in part C1, we calculated the temperature of a helium-4 gas such that the molecules in the gas have a root mean square speed that's the same as the escape velocity. And that number turns out to be about 4,000 Kelvin. That means if the temperature of the helium-4 gas is 4,000 Kelvin, then the root mean square speed of the helium-4 gas would be about 5,000 meters per second. That means at this temperature, half the molecules in the helium-4 gas have sufficient Ke to escape from the surface of Mars. I said half because you got to remember that's the root mean square speed is a kind of average. So if the root mean square speed is equal to 5,000 meters per second, it means that half the molecules have Ke that's more than sufficient to escape, and half of them do not have sufficient Ke to escape. So do you think helium-4 molecules can escape from Mars? It all depends on the temperature of the helium-4 gas on Mars, right? I do not know exactly what is the temperature of Mars on the surface, but 4,000 Kelvin just sounds way too high. It's too hot. Because at this temperature, most gases will be glowing, they'll be emitting light. If Mars is really this hot, then it will give off light by itself, isn't it? So our conclusion is probably the Mars is way too cold, or at least the atmosphere of Mars is way too cold, and the root mean square speed is way too low. So most of the helium-4 molecules will be traveling at speed much lower than the escape velocity. So most of them will not have sufficient Ke to break free from Mars' gravitational field. So they remain trapped in the gravitational field of Mars. Okay, I hope I've made it clear. Ta-ta!